like the acceleration. 1.4 number 55.
I'm curious.
Okay, and then
1.5 number 25.
1.5 number 25.
Take a logistics problem.
Yeah, logistics. The main two probably most likely I will put. I'm gonna look more to it, but most in applications, the most obvious two that I probably will put is a logistic one and the velocity acceleration model problem. Okay. You also know how to do phase shift. So that's not an application. That's just a 2.2. You should know how to do 2.2. You guys all remember 2.2, right? Stable, unstable, critical points. You know, right? Solve differential equations using partial fraction decomposition. Differential equations that are autonomous, right? And then you factor, find the critical points, right? And then do partial fraction decomposition to solve, right? That type of stuff. Yes.
1.6, can we do 11? And
1.6, 11 and 5.
You already have that there.
Well,
You have 1.6.
right. Yeah. No, I want to go through the order of what was called 1.6, 11 and 5, and something over there. Yeah.
1.4 number 61.
1. What was it?
4.
61, right? 1.4 number 61. And anything else? Yes.
2.2 number 5.
2.2 number 5. Any other questions? Yes.
For 2.1, the second part of the problem where you have to do it in particular, I wasn't sure how to do that.
Okay, so which particular problem?
I think any one of the first 8, I guess.
First 8, okay. 2.1, how about number 7?
Sure.
7. Yes. 1.538. Okay, now let me first do these first, and then if we have time left, we'll do more, or we'll take a quick break and come back to these things. Okay. All right. So let's take a look at 1.6 number 13. 1.6 number 13. Number 13. We have here is x, y prime equal to y plus square root of x squared plus y squared. Okay. Now, at first, you may notice that. So if you look at 1.6, guys, 1.6 is about what? Substitution. So we're talking about either some kind of substitution, a homogeneous equation, or a Bernoulli type of equation. Some kind of substitution going on, right? Okay.
It tells you at the beginning that they're all homogeneous.
Yeah, so it's most likely homogeneous. You can see it's homogeneous already. Order 1, order 1, order 1, because it's square root of a square. You guys all see it's all order 1. You guys all see that, right? So this should be an order 1. What's the highest power of x? Highest power of x is x. X to the 1 power. You guys all notice that, right? So you want to divide here by, guys, x. Okay? So divide everything by x. And here, when you divide into inside of the square root, it goes in as, guys, x squared. Everybody agree with that, right? When it goes inside the square root, right? Okay. So now then, this will turn into y prime equal to y over x plus square root of 1 plus y over x, the whole thing, squared. Everybody's good? So far, so good? We distribute the x squared. So that's 1 plus y over x, the whole thing squared. Everybody follow the algebra there, right? Simple algebra there. So you make now the u substitution. U is equal to y over x as this being a homogeneous equation. You guys all see, right? Now then, this will turn into, guys, as a u, how does it turn into? Well, no, this side, this here. What does this thing turn into? U plus, right, 1 over, oh, sorry, root of 1 plus, guys? U squared, just like that, right? Everybody agree so far? Okay. So that's what we have there. And using this substitution, the differential equation, if you recall, turns into x du dx equal to f of u minus u. That was something you needed to memorize. Are you guys okay? Or you can derive it. I hope you can save time by memorizing this equation instead of trying to derive all the time. Everybody understand what I mean, right? You can definitely derive it, but it will take longer time. Are you guys okay, right? Okay, so if you can memorize it, it would be better, right? So this equation right here, whenever you make this homogeneous substitution, that is the differential equation you end up with. Everybody's good, right? Okay. All right. So with that in mind, now f of u is right here. It's y prime equal to f of u. Are you guys okay? So then this equation turns into x du dx equal to u plus square root of 1 plus u squared minus u. Correct? Everybody see? So now you see that it's separable. Every time you do this, it'll turn into a separable equation, okay? So this is separable. And the u's cancel, you can see. And let's separate it. So this will now become 1 over square root of 1 plus u squared du equal to 1 over x dx. Everybody's good so far? So far so good? Everybody follow so far? Right? Okay. Now you're going to have to integrate this. Okay. Now the integral of the left-hand side turns into it's an equation involving a tangent substitution. I think it's not quite arctan because of the square root. Okay, it's a hyperbolic, some kind of hyperbolic. I think it may be hyperbolic sine or hyperbolic tangent. Now I would have to look this up. Okay, let me take a look here. We have it here, so it should be easy to look at. They don't have the non-standard one. Sine hyperbolic? Yeah, I think that's what I thought. It was, it's not cosine. Cosine is the one with the minus. Okay, so this is the plus one is most likely the sine. Okay, sine hyperbolic. Okay, so this is
There's also
this is
log
what was that?
I looked it up and I saw like a natural log form of it, and that's how I got the answer to this.
Oh, natural log form of it. Yes, but most likely.
It's like ln of u plus square root of u squared.
The ln of the
I don't know what that is.
Okay, sure. Hold on. I think the natural log would work better because you have natural log here and natural log there. Okay. Yes. I will not give you things that are this difficult on the test, right? Like the ones that you would have to look up, like a table example. It's not the table integral. Are you guys okay? So what was it? Natural log of u plus square root of
Yeah, u squared plus 1.
u squared plus 1 plus u squared, right? Like that.
That's where it got stuck too, so you don't have to finish.
Yeah. Yeah. So you needed a little table.
Why did sine hyperbolic if you couldn't get the right answer?
Right. Well, no, you got the answer. It's just in implicit form. Okay. And you can stop there if you want to stop there. Okay. Yeah. And I'm not going to give you something that is like that. Okay. So if you were to write it as natural log, that would be best because you have natural log on the left and natural log on the right. Right. So this would work much better. Okay. And then you can solve from here. Get rid of the log. This would be u plus square root of 1 plus u squared equal to a times x. Everybody's good, right? A times x, because of the exponential that's gonna go on here. Exponential, just like so. Okay, so they will cancel. Okay. Now I'm not gonna give you once again, not these ones that you have to use table. The only thing I would probably assume that you guys know is the tangent, arctan, the integral of 1 over, not with the square root, but guys with just 1 plus q squared. That one is so prevalent that I would assume that you know arctan. But other than that, nothing that's this complicated. Yes.
So I get that e to the x is or e to the c is a constant, but why is it a times x?
Because we've done this a lot of times, and we will continue to do this a lot of times, right? This will turn into e to the c, right? And e to the log of x, correct?
Using the rule of
Right, this is law of exponents, correct? When you multiply, you add, right? Now, e to the c is an unknown constant, correct? Right? So e to the c itself is an unknown constant. So this right here
Yeah.
is your a. A times e to the log x,
Oh, okay.
and that's x, right? And so this a is actually a positive constant, some positive unknown constant.
Okay.
You got it, right?
Yeah.
And this will be kind of like a recurring theme. We'll do this kind of simplification all the time.
On the test, can we write that e to the c is like a big C or something like that?
Yeah, something like that. Any kind. You don't have to use a. You can use another constant, k or whatever. Here you have.
yeah, it's just that's the same thing.
Oh yeah, okay.
On the test, do you want us to back substitute for you to solve for anything?
No, not. Well, I'll be explicit about it. I'll say solve the differential equation implicitly. When I say that, you don't have to solve for u. Okay, right? Oh no, here. Oh, sorry. I didn't finish. Yes. You do have to, right? You do have to, because u is what is it, guys? Y over x, and I would have to back substitute. I thought you meant go on here further. So now I would have to back substitute, solve for y. So this is y over x. Yes, definitely you should solve this with the original. By the way, this right here, this expression, now I'm going to be a little bit clever about it. This expression is this one, guys, right? This one is this one, right? And this one is that one, right? You guys all see over x, right? Yeah, so maybe I can write it, instead of like that, I can write this as, guys, y plus square root of x squared plus y squared equal to ax squared. You guys all see why I get ax squared?
Multiply by x.
Yeah, because you have to multiply by an x. You see, this one has an x on the other side. Right? Everybody see? So I can rewrite it just like that. That will look a lot better, right?
Oh, I see. Yeah.
Okay.
If we just substitute y over x into this.
Yeah, that would be fine.
Okay.
Yeah, that would be fine. Yeah, I just wanted to make it look nice for you guys. Yes. Definitely. Yep. Everyone's good? Any questions? And this is where you would stop. Yes. And you don't have to solve for what. That would be fun to you. Yep. Okay. Okay. So now let's look at number 1 on 1.6 as well. So number 1, it's again it's a homogeneous equation. Number 1, x plus y prime is equal to x minus y. So here it's homogeneous, highest power x. We divide everything by, guys, x.
Plus y.
Well, x, just x, right? X, right? So this would turn into 1 plus y over x, y prime equal to 1 minus y over x. So if you were to make the substitution u equals y over x, then you can see that y prime is equal to what, guys? What's y prime equal to?
1 minus y over x
Which is u, right? 1 minus u
over 1 plus u.
over 1 plus u. So that is your function of u. You guys all understand, right? That's your f of u. So now again, you memorize this thing. This equation right here, right? So then the differential equation turns into x du dx equal to f of u minus u. Are you guys okay? So this is 1 minus u over 1 plus u minus u. That's a separable equation, but before I do separate it, let me make common denominator and simplify a little bit, right? Okay? So here I would multiply top and bottom by 1 plus u, for example. And that will help out a little bit, right? So this will turn into 1 minus u, okay, minus u squared. Okay, is that right? And over 1 plus u. Simplifying a little further, I have x dx du is equal to
du dx?
du dx. Thank you. Du dx turn into this one factors out as 1 minus u. Oh no, it doesn't factor out here. Sorry about that. This is a minus u squared, right? So 1 minus 2u minus u squared over 1 plus u. Just like that. That's fine. Okay? So now then, let me separate that out. So if I separate that out, I get 1 plus u over 1 minus 2u minus u squared du is equal to 1 over x dx. Now this one's a little tricky one where you need to recognize that this part is your substitution derivative. The chain rule derivative. You derive the inside. So basically what you're going to say is this is your, guys, w. You make the substitution, you guys, okay? So you let w equal to 1 minus 2u minus u squared. Then dw is equal to, guys, what's your dw equal to?
Negative 2
Negative 2
minus 2u.
2u du. Differential must equal to a differential, okay? Right? So now then you can factor out a negative 2. dw is equal to negative 2 1 plus u du. It's very convenient. As you recognize all the homework exercises are always set up so that it's very convenient, right? Okay, so you can see 1 plus u du right here. 1 plus u du right there. Do you guys all see? So 1 plus u du turns into negative 1/2 dw, making that substitution as well. This will turn into negative 1/2 integral of 1 over w dw equal to integral of 1 over x dx. So the integral antiderivative of that is what?
Negative 1/2
ln of w. Let me substitute it back to the u, guys. So this
ln
is
u plus 1.
negative 1/2
Or
ln of w is
1 minus 2u.
1 minus 2u minus u squared. Like that. Okay? And then equal to, over on the right side is, guys, ln of x. Now, plus c. Now you can just leave it like that, and not leave it like that and solve from here. But I don't like to have like a constant in front of the larger log, right? I like to have the constant in front of the, guys, smaller log. So I'm going to multiply negative 1/2 to the right side. Are you guys okay? That'll make the whole thing nicer. Are you guys okay? Right? So if I multiply negative 2 on the right, both sides, this left side becomes natural log of 1 minus 2u minus u squared equal to negative 2. Well, what's negative 2 in the log? It goes up here as, guys,
X.
negative 2, x to the negative 2. So this is natural log of x to the negative 2 plus c. Negative 2 times c is still, guys, constant, we don't know, right? So just like that. And then I'm going to take e of both sides, and again, that same little trick here. That c is going to come out as an a in the front, as a multiplication by a scalar, okay? Right, so here I have 1 minus 2u plus or minus u squared is equal to a over x squared, or a times x to the negative 2. Everybody's good? So far so good, right? So now then I'm going to go back to my u. U was x over, guys. Y over x, so put it back to that. So then you get 1 minus 2y over x minus y over x, well, y squared over x squared equal to a over, guys, x squared. Now you can kind of see that it would look a lot better if I multiply everything by, guys,
X squared.
x squared. So if I multiply everything by x squared, I get x squared minus 2xy minus y squared is equal to a, some constant a. So there's your general solution, which is rather nice looking example. Yep, everybody's good? Any questions? Any questions? Okay, all right, great, very good. So now then, let's look at number 19. Number 19, separable. Homogeneous equation. Once again, so here x squared y prime is equal to plus 2xy is equal to let's see here 5y cubed. Okay, so what you'll notice here is that it's not homogeneous, correct? It's not. It's a square, degree 2, but degree 3. So it's not, homogeneous. You guys all notice that? Yes.
So
Question?
for the left-hand side, you would just, the total degree is 2, or is it?
Yeah, it's every term, right? 2, 2, and this is 3. So it's not homogeneous.
So
You
the
all see?
left-hand side counts as 2, not 4.
2?
Left-hand side, the degree counts as 2 and not 4.
Yeah, degree counts as 2. Yes,
Okay.
yes.
Is this number 19 for 1.6?
I think so.
Yeah, that's the right one.
Correct? Yeah, it is. It's not homogeneous, but what is this one? We knew the other substitution equation, right? Bernoulli. This is Bernoulli, correct? Bernoulli is where you have y prime plus, guys, p of x y plus q of x y to the n, some n powers, right? So this is like a linear, except you have y to the n power on the right. You guys all see, right? Now let me put it in the right form. If you remember Bernoulli, you should just have y prime on the left, right? Okay, so I'm going to divide everything by, guys, x squared, right? So let me divide everything by x squared. So y prime plus 2 over x y equal to 5 over x squared y cubed. If you recall Bernoulli, what was the substitution that you need to make here? U is equal to y to the 1 minus n. So that is your substitution. Okay, you need to make that substitution. Or in other words, u is equal to, in this case, y to the negative 2. That's your substitution that you make. Everybody agree? Right? Now when you make that substitution, this changes into a linear equation. You guys recall the linear equation that this changes to? This changes to, guys, du dx plus 1 minus n p of x y equal to 1 minus n q of x. So it changes to this equation, right? And this you also need to memorize and try not to derive that all the time, right? So when making that substitution gets you to this. Everybody see here, n is equal to what again? N is 3. So you just plug those things in, right? So then this differential equation, the new differential equation that we get is du dx plus negative 2, right? P of x, which is 2 over x. U, oh, sorry about that. That was not y. It should have been a u. My fault. U. My fault there. I made a little change right here. It wasn't y, guys. It was u. Okay? So u equal to negative 2 q of x, which is 5 over x squared. Like so. So that's your equation, right? Let me just kind of multiply that out a little bit and simplify a little bit.
And the, yes, the u came from the equation.
Oh yeah, this u came from the equation. This the changes into this.
Okay.
Okay? So u dx minus 4 over x, that's your p of x u, equal to negative 10 over x squared. So now once you make that change, okay, this becomes, guys, linear. And you have that 3-step process of linear equations, right? Rho of x is equal to e to the, guys,
Negative 4 over x.
integral, antiderivative, negative 4 over x dx, which would give you, guys, here, e to the negative 4 natural log of, guys, x. You don't have to do plus c here, okay? Because they actually cancel. So here you get
E to the x to the negative 4.
x to the negative 4. Just x, the log and e
Yeah.
cancel, right? So you get x to the negative 4. Everybody's good? So that's your row. That's your row. Everybody's good? That's your row, x to the negative 4. Okay? Now, this left-hand side then turns into, when you multiply both sides by this, right? The left-hand side turns into, guys, d dx of rho u, not rho y, because u is your top variable, dependent variable here, right? So, x to the negative 4, u equal to, the right side turns into, you just multiply that out, you get negative 10 x to the negative 6. I'm going to write it as a power form. For the reason being is because I need to take the antiderivative of it. Right? Everybody understand? Because I need to take the antiderivative of that, right? Do you guys all understand where I got negative 10x to the negative 6? So I'm multiplying this to this equation right here. So that's negative 2, negative 4, negative 6. Yep, everybody follow this problem so far? So far so good? Everyone's good? Okay, good, very good. So now then all I need to do is take the antiderivative of both sides, antiderivative or integral of this side. Fundamental theorem of calculus says this thing cancels. On the left you just get x to the negative 4u. You get x to the negative 4u equal to, the right hand side is the antiderivative, so this will give me a negative 10 over negative 5, x to the negative 5 plus c. Correct? Everybody's good? Okay, so now I get rid of this x to the negative 4 and solve for u, or you can put u right away if you wanted to, right? Either way. So now then here you get, guys, u is equal to 2x to the negative 1 or 2 over x, correct? Okay? And then plus c times x to the 4th. Everyone's good so far? Finally, put back the y. Put back into y. U is equal to y to the, guys, negative 2. So y to the negative 2 equal to 2x to the negative 1 plus c x to the 4. That's good enough, but the book might want you to write it like this. I don't know if they do or not, but they may want you to do this. You don't have to. No, not like that. You want square. Square root of. So this would be a square root of. Plus or minus, actually. Right? Everybody's good? So something like that. This would be fine for me. Or just. Everyone's good? Any questions? Yes.
With the with these equations, because it's like I know we're doing it's the Bernoulli's.
Right.
Is that when it only when it has a power to the third power?
No, if it Bernoulli
Could it have-
is where you have power of y on the right side. It looks like linear.
P of x equals q.
Yeah, px y equal to qx y to the n.
Would you ever be able to do this where it's separable?
Yeah, sometimes they may be separable. Like for example, if this was not there, if this power was either 0 or 1, it is a separable.
But you couldn't do it where it's the u equals y to the 1 minus 7. That's only the Bernoulli's equation.
Right.
Okay.
Yeah. If it's 0 or 1, you can do it like this too, but you don't want to. You want to do it as a separable. It's much easier that way.
And then one more question too, like where it says y prime plus 2 over xy, could that be y squared? Would that change the equation if it was 2 over xy squared?
2 over x y squared,
Yeah.
here y squared,
Yeah.
yeah, that would change the problem. That
So
would not be a.
You wouldn't be able to do.
Yeah, the over here has to be a y.
Okay.
Any other questions here? Any other questions? Okay. Yeah. If this was a y squared, you would need a degree 3 here, and then it would be a homogeneous, and you can go on from that. But otherwise, you won't be able to do. Okay. Any other questions here? Any other questions? Okay. So that's 1.6. Let's look at 2.3, number 11 now. 2.3, which is acceleration velocity model. Number 11, according to a newspaper account, a paratrooper survived a training jump from 12,000 feet. So this is the linear the acceleration velocity model, where there's an air resistance, right? Where we have dv dt is equal to minus rho v minus g. Okay? So now, if that happens, you can solve for v. Now, I don't quite remember the formula, but I'll get it soon enough right here. So v of t is equal to v naught minus v tau, which is the terminal velocity, okay, e to the minus rho t, okay, plus v tau. Now, if you remember, v tau is equal to negative rho over negative rho over g, negative g over rho, negative g over rho. Negative g over rho. Okay? So that was v of t. Now, taking the antiderivative and plugging it in as well, and using the initial condition, your y of t is equal to y naught plus v tau t plus 1 over rho v naught minus v tau 1 minus e to the negative rho t. Okay, so this was the equation for a object that was falling or going up, where the air resistance depends on the linear form of the velocity. Okay, right? All right, so that's number 11 here. That was a formula that you're going to use, and according to this newspaper, survived the training jump from 12,000 feet. So your y naught is equal to, guys, this is number 11, 12,000. Okay? When his parachute failed to open, but provided some resistance by flapping unopened in the wind, allegedly, he hit the ground at 100 miles per hour. So his last final velocity, his velocity at the end, was he hit the ground at 100 miles per hour.
Why not 1,200 or 12,000?
What was that? It's 1,200 feet, right?
Okay.
Yeah, but that's what it says. Well, I'm just going, yeah, why not 12,000? But
I think you said that.
yeah, but it says here. So, okay. After falling for 8 seconds, so after 8 seconds of falling. So what that means is that, guys, V of 8 is equal to 100 miles per hour. I have to either decide to do it in miles per hour or feet per second, that type of stuff. I think G is in feet per second, so I probably want to change miles per hour to feet per second. Are you guys okay? So here, what is miles per hour in feet per second? How many feet are in a mile? 5,280. So I have to multiply here by 5,280. Divide by 3,600, is it? 3,600 seconds in in an hour times 100. So that should give you some kind of value there. Somebody with a calculator, help me out. What is it? 2.9 feet per second. 2.9. 2.9 only?
2.93333.
Okay, 333. Okay. Yeah, feet per second. Okay. So something like that. Okay. And then let me see what my question is here. Okay. Test the accuracy of the account. Okay. Suggestion. Find rho in equation 4 by assuming the terminal velocity is 100 miles per hour. Then calculate the time required to fall 1,200 feet. So
It's
It's
You're
not.
on 46.6.
what was that?
I was on
146.
46.6. Or
No, I was on 500.
So 500? Yeah.
146.6.
This one 146.6? Okay. 146.7, okay, 8%. Yeah, I thought that was rather slow. Yeah. But, yeah.
So that's just
No.
You're just very.
But anyway, so there's your repeat. So what they want you to do is calculate the validity of this account. So this is the report. Calculate the validity of this report. As you've seen before, terminal velocity is reached fairly quickly in most situations. So in about 8 seconds, this will be the terminal velocity. Are you guys okay? So let's assume V tau is, or absolute value of V tau, terminal speed, is 100 miles per hour, which is 146.7 feet per second. Now, with that in mind, find time when y is equal to, guys, 0. When he hits the, guys, ground. And let's hope this time, he is close to, guys, 8. You guys all understand or confirm that he is close to 8? Everybody understand what's going on? Right? Okay. So then we have the validity of this account. Okay? So let's take a look at this, right? So V tau, from V tau we can get, guys, rho. Do you guys all see, right? V tau is G over rho. So I know that G over rho is equal to 146.7. G is 32 over rho is equal to 146.7. So rho is equal to what? Try not to use this thing, but use the original numbers and divide it by 32 and see what you get. let me see with my calculator.
0.21.
It should be fairly small, between like 1 and 2 or something like that, or between 0 and
0.22.
0 and 1 or something. Very small, yeah, point something. 0.22, is that right? Let me get the. Okay, so and then divide by 32. 1 over x. Yeah, 0.218. I'm gonna go even further. 0.218. Yeah. 0.218. Yes. You had a hand up there?
Yeah, should it be minus G over rho, or is it because it's going down?
Yeah, it's going down, it's minus, but I'm talking about the speed.
Right.
So it's an absolute value, so this absolute value, you get rid of the minus. Yeah. Okay. So I get rho equals 0.218, right? Everybody's good? Right, okay. So now with that in mind, I'm gonna now plug it into this. Solve for t when y is equal to, guys, 0 and y naught is 1200, right? And the terminal velocity equal to? Terminal velocity equal to? 146.7. Be careful. This v tau is, guys, positive or negative? Negative. Okay, when you plug it in here, you have to use, guys, negative 146.7. Everybody's good? Okay, so let's put it in and see what I get. To solve for t here, I may need to use some kind of algebra system. Are you guys okay? Like a Wolfram alpha or something like that. Okay, this is not going to work. Everybody's good, right? Some kind of calculator. Yeah, this won't work with us. 0 is equal to 1200 minus 146.7 t. Right, plus 1 over rho, so 1 over rho, 4.58333, 4.58333. Okay, v naught, which is which is 0. Now minus v tau, which is 146, so plus 146.7. Okay, and then 1 minus e to the negative 0.218 t. And hopefully you solve for t, okay, which I don't have the calculator capacity to do. Okay, I need a better calculator. You guys should have a calculator that lets you solve these things, no?
Yes.
No, no. Well, those of you who have those of you who have like TI 80 something type of versions, you should be able to solve it. Yeah.
So the guess is we probably won't have anything that
Yeah, not
that
something.
needs Wolfram.
Yeah, not something. I would have to reword the problems so that you wouldn't have to solve for t. You solve for like y or something.
You could guess t is equal to 8 and then see if it's close.
Yeah, see if it's close. Yes, that's a better idea. Yes, great. Yes.
Can I ask you after class how you solve for t?
Oh,
that's
this one?
That's
No,
like the
I'm-
one reason I wanted
It's
to
not.
do
It's
this.
not something that's very, very easy. I would say it would probably require some kind of numerical method. The book talks about Newton's method. So you can always do this, but it would take several steps. Oh, you would have to guess something close to 8, right? And then you guys remember the second guess. So let's say your guess is x sub n, right? Then x sub n plus 1. If you recall from Newton's method, if this is xn, then you have to solve for this value. This one is f prime of xn. That's the slope. X minus xn equal to y minus f of xn. F of xn. So you want to solve when y is 0. So when this is 0, that's when this crosses. That's your xn plus 1. Your next guess, that's Newton's method. Are you guys okay? Right? So I'm solving for Newton's method, so I'm solving for this x. So I see that that is x of n minus f of x of n over f prime of x of n. Yeah. So I would have to do that. So I would choose something close to 8 first. Like I would plug in 8, t equals 8, and then take the derivative. I would have to have a derivative of this, which is not hard to do, right? The derivative of this, right? You have this, and then you take a derivative of that, right? Okay, multiply this out, right? And then you plug in t equals 8 there, plug in the value for t equals 8, go on several times until, like, if you want to get it close to the hundreds, 100 places, repeat. Yeah, which is not a good thing to do. You'd have to, run this calculation quite a long time. You guys remember when you were doing Calc 1, Newton's method? It's a long time. It takes a long time. It takes a long time, especially if it's not a computer calculation, right? To do by hand, it takes like 10, 15 minutes to do it, each problem. You have to do it until various values of each. Okay? I want to make sure that I got this formula right. Yeah, that's right. Everybody see it, right? Yeah. So that's Newton's method. You guys remember your Newton's method, right? Yeah. You should be able to derive your Newton's method, guys. This is your derivation of Newton's method quickly, right? I forget the formula, so that's why I'm strong, right? Yeah. But anyway, that's your Newton's method. Hopefully you remember your Newton's method. Okay. Anyway, so hopefully if you do that, you get t value which is close to, guys, 8. Okay. 12.45, you were able to figure it out? Well, well, that's great, 12.45. T is equal to 12.45. If it is, let's say, if it is, well, it doesn't, it doesn't matter if, I just want to kind of see if it's valid or not. If it is, then the newspaper account here is not quite valid, right? You guys all see? It's not exactly valid. It took a little longer to drop. Maybe he had a variable drag constant, like he was going up and down a little bit. His terminal velocity is when he was his parachute was like.
I mean, how did they know that he was 8 seconds? If he was counting.
It's very difficult. He may have a watch on him. Maybe the watch broke at 8 seconds. I don't know. It's not. That would be really difficult. And how did they know he dropped it, guys? 100 miles per hour. He didn't have like a speedometer on it. That would also be very difficult to calculate. But it's basically, did he survive type of thing, right? Okay. Yeah. Hopefully. Yeah. And if he survived, what would have been his speed? The most interesting question type of these type of thing is, what would be the velocity when he actually dropped? And that's very close to the terminal velocity, right? So what would be the terminal velocity if he actually dropped? And then you can, at a safe lab, you can actually figure out his drag coefficient, approximate the drag coefficient. You have like a wind tunnel with a guy with like a, broken parachute, kind of doing it, figuring out the drag constant, and figure out what terminal speed he dropped in, so that can kind of approximate the speed he upon his impact. You guys all understand what I'm talking about here, right? Okay. So that would be the most efficient way to use that equation, I would say. Okay. All right. So 1.4 now. Let's look at 1.4, number 55. Yes. Yes, I am. I'm going to make a little sheet right out on the equations that you should use, okay? And I'll pass it out for you to test. Okay? Just like handout, okay? Okay. So now let's look at 1.4. Number 55. Suppose that a tank in problem 54. So this is Torricelli's problem. Looks like Torricelli's problem. And here we have that 1.4, 5. And Botticelli's problem here, and we have dv dt. So a of y dy dt is equal to minus a square root of 2gy. Okay? And here it starts from the fact that dv dt is equal to negative a square root of y. So from here, you can get that little result, okay? And let's see here, number 55 here. We have, suppose a tank in problem 54. So let's look at the tank in problem 54. Tank is shaped like a vertical cylinder. So here, area is constant. Tank is shaped like a vertical cylinder. Okay. It initially contains water to the depth of 9 feet. So y naught is equal to 9 feet. Okay. And the bottom plug is removed at time 0. Okay. After time 1, depth of the water has dropped 4 feet. So y of 1, let's do it in hours, okay, is 4. So 4 feet drop, so it's 5. Okay. How long does it take for all the water to drain from the tank? So basically, what is time t? T equals what? When y is equal to, guys? 0. Okay? Suppose the tank, well, that's 54, by the way. Suppose that tank in problem 54 has radius of 3 feet, okay? So this radius here has 3 feet, okay? And the bottom hole is circular with radius 1 inches. Okay, so this is circular with here 1 inch. Okay, 1 inch. How long does it take for water initially 9 feet deep to drain completely? So here, that's not really important now. They just want, this is y, and they just want time when y equals 0. So that's pretty simple now. All you need to do is plug these things in to figure out these values here. You have to solve this dy dt. Let me see if, yeah, we don't have to. We can solve it as we go along. So let's get this differential equation first. What is a of y, by the way? What's the area? What's the large area? Cylinder is not nice because it's not a variable. It's a constant. You guys all see the cross-sectional area is always constant, right? And what is the cross-sectional area? 9 pi, right? Pi r squared, 9 pi. Everybody's good? Right? Capital A here, A of y is constant as 9 pi. Now lowercase a, guys, lowercase a, the little drain hole is what? Pi over 144, right? Because it's 1 inch radius, which is 1 over 12 feet, right? So pi over 144, everybody's good? So you put these values in here, right, and solve this differential equation, okay, which is separable, by the way. Are you guys okay? So you should be able to do that pretty simply. So let's take a look at it. 9 pi dy dt is equal to negative pi over 144 square root of 2g, this is in feet, right? So 32 times 32 y. How did you get that? Oh, this radius, the lowercase radius, let's call this lowercase r, this one capital R, right? Capital R is 3, right? The lowercase r is 1 over 12. It's 1 inch, right? Right, so pi r squared, 1 over 144. Okay? So that's what we have here. Everybody's good so far, right? So what's 2 times 32, by the way?
64.
square root of 64?
Eight.
8, so it comes out as an 8. The pi's cancel here. So 9 dy dt is equal to negative 8 over 144. I think that would simplify as well. Square root of y. Okay, so that would simplify nicely as well. So I'm going to bring all the constants to the right. Okay, so it's actually, yeah, so I'm going to simplify this, multiply by 9. So here I get y to the negative 1/2 dy is equal to, I'm going to separate it, this is a separable equation. 8 cancels, 8 goes into 144, how many times? 18, so, and 18 times 9, 162, is that right? 162, so it's negative 1 over 162 dt.
Pi.
No pi, pi's cancel.
Oh,
Yeah,
okay.
because you have pi on the both sides, right? Pi's cancel, right? Everybody's good so far? So that's what we get. Simple separable equation to solve, right? Use my initial condition to get a particular solution, then solve for, guys, t. Everybody see, right? Okay, so let's integrate both sides here. And when I integrate, I get 2 times y to the 1/2. 2 times y to the 1/2 equal to negative 1 over 162 t plus c. I should be able to use my initial condition to figure out c. When I use the initial condition, this is 9, so it's 2 times 3 is equal to negative 1 over 162. Sorry, I'm plugging t equals 0, so that's c. c is equal to, guys, 6. So c is 6. So the equation then is 2 times y to the 1/2 equal to negative 1 over 162 t plus 6. So what am I doing now?